Hello grade 8s, this is Mr. Miller and welcome to lesson 6.5 on dividing fractions and mixed numbers. So first part here we're going to fill in some blanks and then we're going to write the division statement including the quotient that matches the diagram. The first one is actually already done for us, and one thing that you may want to do on your page right now is just to separate examples a little bit, draw a line right here and another line right here. Just make it a little bit more clear where one example ends and the next one begins. So, like I said, the first one is already done for us. We've got, if you take a look at this here, we have we've got one whole that's divided into 1, 2, 3, 4 parts. And so we're talking about looking at quarters here. And we've got one of these quarters, and we would like to know how many times it goes into the full 4 quarters, or one whole. And it's pretty easy to see how this is represented. How many quarters go into 1? Well, we can do that with a little box here of size 1/4, and I can just move this over and see how many times it will fit into 1. So it's 1, 2, 3, 4 times. Which explains why when we do the division 1 divided by 1/4 we get 4. So this diagram really helps us to understand that process of division. And now let's take a look at the next one and see if we can do some similar kind of reasoning. You can see that you've got one whole here that's divided into 2 equal parts. And we have halves, plus we have another half here, so a third half, or in other words, this is 1/2. And we'd like to know how many times this single 1/2, how many halves are there in 1/2? And so the division statement here is 1/2 divided by 1/2, and we're going to get an answer here as soon as we take a look at how many times this box will fit inside this diagram. So it's 1, 2, 3 times. So the diagram makes it pretty obvious and pretty easy to do. Now let's take a look at the next one where the whole is divided into 1, 2, 3 equal parts. So these are thirds. We have 4, 5, 6 thirds. That's 2 whole. And we have 7 thirds, which is, in other words, 2 and 1/3. So now here we see that the thing that we're trying to see how many times this goes into all of that, this is 2/3. Oops, sorry about that. Redraw that. So how many 2/3 will fit into 2 and 1/3? And so the division statement here is 2 and 1/3 divided by 2/3. And to figure out that answer, I'm going to draw a box of size 2/3 and see how many times I can fit that into this. So I'm going to move this over and I can see it fits in once here, and halfway here. The other half will fit on there. So that's twice, 3 times, and a half. So 3.5 times I was able to fit this rectangle to cover up that entire area there. So in other words, 2/3 goes into 2 and 1/3 3.5 times. So now the diagrams make it easy for you to understand the process of division. How many times does this go into that? But of course, drawing these diagrams every time is a very time-consuming process, and we'd like to have a more efficient way of doing this. So what we're going to be looking at doing next is dividing using a common denominator. And so I'm going to add some notes in red to help you understand how we can use common denominators to do this division. So let's go up to the example that's already been done for us. If we take a look at 1 whole, which is being divided by 1/4, we know that the 1 whole is equal to 4/4. So if I rewrite it in this way where I have the same denominator, a common denominator, then the division is actually quite easy to do, because you can see that 1/4 goes into 4/4 4 times. I mean, we saw that from the diagram, but pretty easy to see that 1 goes into 4 times. In other words, basically what we're doing is just this numerator divided by the other numerator to get our answer to the division question. And the answer to a division question is what we call a quotient. So to get your quotient, or your answer to the division question, here's what you can do. You can divide the numerator by the other numerator. And I guess we should specify which one is which. So I'll do that right now. So we're dividing the numerator of the dividend by the numerator of the divisor. So let me just make it clear what all of these things are. Doing a little bit of highlighting here. So to get the answer to the division question, or the quotient, which is what we have right here, what we do is we take the numerator of the dividend, and that's this right here, and we divide it by the numerator of the divisor. So that's this right here. And obviously you can see that 4 divided by 1 is equal to 4. So you're only able to do this when you have a common denominator here between your dividend and your divisor. So if they have the same denominator, then you can very easily work out by doing numerator divided by numerator of the dividend divided by numerator of the divisor to get your quotient, or the answer to the division question. And we can show the same kind of thing with all these other examples. So for instance, in the 1.5 divided by 1/2, we do have a common denominator here, but it might be useful to write it as 3/2 divided by 1/2. Okay, so working with improper fractions here. And again, to get the quotient, all you have to do is just do numerator divided by numerator. 3 divided by 1 is equal to 3. Okay, so to get the answer to the division question, okay, which I'll highlight here in green, this quotient, to get that, you're going to do the numerator of the dividend, and you're going to divide by the numerator of the divisor. So 3 divided by 1 is equal to 3. And finally, with this example here, we had 2 1/3 divided by 2/3. So the 2 1/3 divided by 2/3 can be rewritten in this way. The 2 1/3 rewritten as an improper fraction. You can see that we have 7/3 lined up here, and we're dividing by 2/3. And to get the answer to this division question, I simply do 7 divided by 2. 7 divided by 2 can be written as 7 over 2, or you can change that into a mixed number again. How many times does 2 go into 7? 3 times with 1 left over. So that's 1/2. And again, just to sort of color code this so that if you're looking back on your notes later and you want to understand how this was done, what was the process to get that answer to the division question or the quotient, what we did was we took the numerator of the dividend and we divided by the numerator of the divisor. Okay, so again, 7 divided by 2 is 7/2, which you can also write as 3 1/2 if you'd prefer to have it as a mixed number. So now that we understand how division can be done, let's go on to dividing with using a common denominator, and now we don't have to worry about this whole process of drawing out these diagrams. Simply a matter of taking a look at these two things and saying, what is the common denominator between these two? Between 4 and 8, common denominator would be 8. So I can double this and double that, and I would get 6/8 that I'm dividing by 1/8, and that would give me 6 as an answer. Again, you're just doing numerator divided by numerator to get your answer. If you're having a little bit of trouble trying to figure out what is the common denominator, what you can do is look at the multiples of these two denominators. So multiples of 4 go 4, 8, 12, and so on. And the multiples of 8 go 8, 16, 24, 24, and so on. And you can see that the smallest number that we have in common here is 8. So there's an 8 here, there's an 8 there. That's why I chose 8 as the common denominator, because it was the least common multiple of those two denominators. So again, if you get the idea of this, what you may want to do is just pause the video, try and do parts B, C, and D on your own, and then come check your answers. Okay? Pause the video now, give that a shot, and then play it and check your answers. Alright, so hopefully you're unpausing the video now, playing the video, and taking a look at your answers, checking them over. So, you can see that the answer, and in each case, when you're doing some work along the way, it might be a good idea to put your final answer in a box. So, for instance, the answer here was 3, the answer here was 3.5. And now for number 2, the answer for part A was 6. The answer for part B was 5/4, and you can write that as 1 1/4 if you'd prefer to have it as a mixed fraction. Either answer will do as an improper fraction or as a mixed fraction. They're both acceptable. Sometimes the instructions will specify which form you should leave it in, so make sure that you pay attention to that. But otherwise, I don't have a preference. Either way is acceptable to me. As long as your answer is in lowest terms, then that's the main thing that you need to watch out for. So now the next thing we're going to do a little bit of an exercise in finding reciprocals, and what you can think of in doing this is flip it. So we'll get to why we're doing that in a minute, but first of all, let's just do a little bit of practice here. So the reciprocal of 1/3 would be 3/1. So you can see that with fractions, all you have to do is just flip it. Whatever is in the numerator goes to the denominator, whatever is in the denominator comes up to the numerator. So the reciprocal of 5/6 is 6/5. The reciprocal of 2 1/3, well, that's a little bit tricky because first you have to change it to an improper fraction, then you can flip it. And again, part D, you need to change it to an improper fraction first. So that would be 4 times 5 is 20 plus 2 is 22 fifths. And now, sorry, these two things are obviously equal to each other. And now changing that to the reciprocal, that's 5 over 22. Alright, so the next thing we're going to do is we're going to divide using multiplication, and this is often referred to as flip and multiply. So what I'm going to do is I'm going to show you how to flip and multiply first, and then I'm going to explain why this method is a valid method. So the flip part is nothing to do with the dividend. The dividend is actually left alone, so 3/5 remains as is. It's the divisor that you flip. In other words, you're finding the reciprocal or the flipped version of that second number in the division statement, which is called the divisor. Now we can actually multiply to get our answer. So we do 3 times 3 is 9 and 5 times 2 is 10. The answer is 9/10. You say, wow, that's great. I want to do that all the time. I don't want to have to draw diagrams. I don't want to have to find a common denominator. But it's maybe important to look at this a little bit more carefully and just make sure that this is truly a valid method. Okay, so this works. This is our final answer, but why? Why is it the answer, and why is this an acceptable method? So to do that, I'm just going to zoom in on this and take a real close, well, maybe not that close, a close look at this question. So the method that we had done before was to come up with a common denominator. So between 5 and 3, that common denominator would be 15. And as long as we had both of these things changed into 15ths, then we could do numerator of one divided by numerator of the other. So to get 15ths from 5, what you need to do is you need to take that 3/5 and multiply it top and bottom by 3. And you can see 5 times 3 is going to give you 15. For the second fraction, we've got 2/3, and we need to multiply it top and bottom by 5. So 5, because 5 times 3 is what gives you 15. And 2 times 5 gives you 10. 3 times 3 gives me 9 here. So now that we have a common denominator, I can get the quotient just by doing numerator divided by numerator. 9 divided by 10 is 9/10. So just like we had been doing before, we're getting our answer here by doing the numerator. Ooh, that's a little bit dark. Let's choose something a little bit lighter so we don't cover up our answers here. So we're doing the numerator of this one divided by the numerator of that one. And that's how we're getting our answer. Right? Numerator of the divisor, numerator of the dividend divided by numerator of the divisor, and that is the answer to our division question. That's the quotient. So take a look at this numerator one step back. Okay? Let's take a look at that 9, the 9 in 9/10, which is it's the same 9 here. One step back. We were getting that by doing 3 times 3. Well, notice that we also have a 3 times 3 here. We did this 3 times, flipped up, that 3. So now you can see why we're flipping. And again, if we go to the other part of this, the denominator here is 10, just like here it's 10. Where is it coming from? If we trace back a little bit, it was 2 times 5. Well, isn't that what we have here? 5 times 2 is equal to 10. So in other words, we're doing 5 times that 2. So that 2 in the numerator here has to flip down in order to be able to multiply. So now you can see pretty clearly why this method of flipping and multiplying works. If you didn't completely understand that explanation, don't worry, it's not the end of the world. The main thing is that you know how to use this method, which basically all you have to do is take fractions, flip the second number in the division statement, which is your divisor, and then you can do a multiplication. So, but before we do that, we've got to change these mixed fractions into improper fractions. So 2 1/4, for instance, is 9 quarters. And 1 1/2 is 3 halves. Now what I can do is leave the dividend alone. Leave the first number alone. Take that second number and flip it. So the 3 halves becomes 2/3. Now, doing this multiplication, I'm going to show you one way. You may not want to copy this down. I'm not real keen on this way of doing the multiplication. Just doing 9 times 2 is 18, and 4 times 3 is 12, and then reducing afterwards, dividing the top and the bottom by the greatest common factor, which would be 6, and that gives you 3 over 2. Sorry, I'm having a little trouble writing here. There we go. So this isn't the greatest method, and the reason it's not the greatest method is because, well, there's actually a better way. Okay, so let's take a look at how we're still going to get an answer of 3 halves, but we're going to do it in a little bit of a simpler way. So what we're going to do is we're going to recognize right off the bat that between a numerator and a denominator, there's a common factor of 3 that we can divide out. Divide out the factor of 3 here, divide out the factor of 3 there. Divide out the factor of 2 here and the factor of 2 there. And now we're doing numerator times numerator, 3 times 1 is 3, and denominator times denominator, 2 times 1 is 2. We're multiplying smaller numbers, and our answer is already in lowest terms. So this is a really nice way of doing it. So if you can remember to do this, this is a better method for you, and that is to reduce then multiply instead of multiplying then reducing. Now if you get how to do this division using multiplication or the flip and multiply method, I suggest you pause the video right now and you do parts C and D on your own, and then you can play the video to check your answers. Okay, we're back. So hopefully at this point you're just checking your answers, and hopefully you were able to get that right. 21 quarters or 5 1/4 for part C, and 32 over 7 or 4 4/7 for part D. Now whether you leave your answer as an improper fraction or a mixed fraction, I don't have a preference as long as your answer is in lowest terms. And the one thing about part D that you just need to be careful of is when you have a whole number, you can write it as over 1. So 8 over 1. Alright, so next we're going to go on to number 5, and we're going to do a write the division statement that matches the problem. We're going to estimate the answer, and we're going to show some work for that, and then we're going to divide and write the sentence answer. So the question is, how many 3/4 cup portions are there in 1 1/2 cups of sugar? So typically when we're doing this, first of all we want to get the division statement. So how many times does this go into that? So we're doing 1 1/2 divided by 3/4, so that's no big deal, just getting the division statement. To do estimates, generally what we do is we go to the nearest half. So 1 1/2 is on a halfway point. 3/4, you could either say it's you could go down to a half or up to 1. So either way will do, but let's say we go down to a half and see how many times. So this is the estimate, so it's not exactly equal, it's approximately equal, and we know that a half goes into 1 1/2 3 times. So that's the approximate answer. To do the calculation, you would take 1.5 and write it as 3/2, and dividing by 3/4, what we can do is do 3/2 times 4/3, so flip, and then we can multiply, divide this by 3, divide that by 3, divide this by 2, divide this by 2. 1 times 2 is 2, 1 times 1 is 1, so 2/1 is 2. Final answer is 2. And writing a sentence answer here, so there are 2 3/4 cup portions in 1.5 cups of sugar. So there we go. Let's take a look at the next one. It says Sabrina has 3 1/3 liters of ice cream to share equally among herself and her 9 friends at her birthday party. How much ice cream will each get? So we're taking 3 1/3 and dividing by her and her 9 friends. That's 10 people in total. So if you're looking to do this approximately, you'd say 3 1/3, well, it's close to 3 1/2. And if we're dividing by 10, then you'd say that, well, 3.5 divided by 10 would give us 0.35. So that's 35 100ths. Which, reducing to lowest terms, divide the top and the bottom by 5, would give us 7 20ths. Okay, so that's our estimate. 7 20ths, you might even want to look at that and say, well, that's roughly a half. I know it's a little bit less than that, but let's take a look at what it would be exactly. Let's do the calculation. So taking 3 1/3 and writing that as an improper fraction, that would be 10/3. And we want to divide by 10, which is 10/1. So now we leave the first one as is, and we flip and multiply. And you can see there's a factor of 10 that divides out here and there. 1 times 1 is 1. 3 times 1 is 3. So the answer is actually 1/3, which is less than a half. And 1/3 is pretty close to 7/20. 7/20 is not exactly 1/3. 7/21 would be 1/3. But anyways, okay, so answering with a full sentence. So each person gets 1/3 of a liter of ice cream. And that's the end of this lesson. Hopefully you understood that, and thanks for watching the video. Have a great day.